Let us take some numerical examples on mesh analysis. Here we will take up three examples and we will solve each question in a step by step manner. So this is example 1. Here a circuit is given with independent sources and resistances, and we are required to calculate the current in this 2 ohm resistance using mesh analysis. So the step 1 is to identify the meshes in the circuit. So here we can see that this circuit has two meshes which I am marking with these two circles. So this is mesh 1 and this is mesh 2. Once you identify the meshes, the second step is to mark the mesh currents. Mesh currents can be marked either in clockwise or anti-clockwise direction, but for the sake of convention, we will always take mesh currents in a clockwise direction. So I had these two meshes, mesh 1 and mesh 2, and I am marking the mesh currents in clockwise directions. Once we have marked the mesh currents, we need to write the KVL equations for these two meshes to obtain the values of these variables I1 and I2. So here we will take rise in potential as negative and fall in potential as positive. So first I'll write the KVL equation for mesh 1. So I'm starting from the lower potential terminal of this 12 volt source. So as we move in a clockwise direction, first of all I see a rise in potential which is equal to 12 volts. So I take the value as minus 12. Then on my way I have this 2 ohm resistance, the current through which is I1, and it is along the same direction in which we are moving. So there is a fall in potential, and this fall in potential I'll take with plus sign. The value of resistance is 2 ohms and the value of current is I1. Now on my way there is a resistance of 12 ohms which is common between the two meshes, and if we see the current through it in a direction top to bottom, then the value of current will be I1 minus I2. So that is a fall in potential again. So I'll take it with a positive sign. The value of resistance is 12 ohms and the value of current is I1 minus I2. Now on my way I'll have this 4 ohm resistance, the current through which is I1, and there is a fall in potential. Again I'll take it with a positive sign. The value of resistance is 4 ohms and the current is I1. So I'm back to the point from where I started. So the sum of all these potential differences should be equal to 0. So this will be the KVL equation for mesh 1. Now I'll write the KVL equation for mesh 2. Here I'll start with this point in a clockwise direction. So first of all I'll have this 9 ohm resistance on my way, the current through which is I2, and it is along the same direction in which I am traveling. So there is a fall in potential and hence I'll take it with a positive sign. The value of resistance is 9 ohms, the value of current is I2. Then I'll have this 8 volt source on my way and you see a fall in potential. So again I'll take it with a positive sign. The value of potential difference is 8 volts. For this 3 ohm resistance the current is I2. There is a fall in potential, again a positive sign. The value of resistance is 3 ohms and the current is I2. Now we come to this 12 ohm resistance. If we see the current in a bottom to top direction, then the value of current will be I2 minus I1, and that current will be in the same direction in which we are moving. So that's a fall in potential and hence I take it with a positive sign. The value of resistance is 12 ohms and the current in bottom to top direction will be I2 minus I1. Now I am back to the point from where I started. So as the final step, we need to solve these equations to obtain the values of I1 and I2. And since we were required to calculate the current through this 2 ohm resistance, we see that the current through it is I1, and in terms of branch current, we see that the current is from left to right direction. So if we solve these equations, we get I1 to be plus 2 by 3 amperes, which means that the current through 2 ohm resistance is from left to right and its magnitude is 2 by 3 amperes. So these are the 4 standard steps which will be followed in the upcoming examples also. So in example 2, we have taken a circuit which has got dependent as well as independent sources. Here we see that this source is a current dependent voltage source. It is dependent on a current I0 which is flowing through this 10 ohm resistance. So once again, our first step is to identify the meshes in the circuit. So there are 3 meshes we can see here, which I am marking with 3 circles here. So this is mesh 1, this is mesh 2, and this is mesh 3. Now once you have identified the meshes, you need to mark the mesh currents in clockwise direction. So for the mesh 1, I am marking the current as small I1. For the mesh 2, I am marking the current as small I2 in clockwise direction. And for mesh 3, I am marking the current as I3. So since we were required to calculate this current I0, here we see that I0 can be expressed in terms of I1 and I2 because this 10 ohm resistance is a common branch between mesh 1 and mesh 2. So this I0 is equal to I1 minus I2. So once we know I1 and I2 and we find their difference, we'll be able to calculate this I0. Once we have identified the meshes and marked the mesh currents, we need to write the KVL equations for all these meshes. So again, I'll follow the same convention of taking rise in potential as negative and fall in potential as positive. So for mesh 1, I'm starting from this point. The equation will be minus 24 volts plus 10 I1 minus I2, then plus 12 I1 minus I3 is equal to 0. Similarly, for mesh 2, the KVL equation can be written as, I'm starting from this point, so this equation is plus 10 I2 minus I1 plus 24 I2 plus 4 I2 minus I3, and that is equal to 0. And finally for mesh 3, I am starting again from this point in a clockwise direction. The equation is plus 4 I3 minus I2. Now this is a voltage source and it is a current dependent voltage source. We see a fall in potential, so this will be plus sign and the value of potential difference is 4 I0. Now I'll have this 12 ohm resistance on my way, so there is a fall in potential with I2, the current as I3 minus I1, and this is equal to 0. So now we have 4 equations here, I1, I2, I3 and for I0 also, and once we solve these equations, we will be able to calculate the value of I0. So once we solve these equations, we get the value of I0 as 1.5 amperes. As a final example, we have taken up this circuit which has got a current source in it. So here we are required to calculate the current in this 8 ohm resistance. Now the steps will be the same. So first we need to identify all the meshes in the circuit. Here we see that there are 3 meshes which I am marking with these circles. mesh 1, mesh 2 and mesh 3. Once we have identified the meshes, again we need to mark the mesh currents, and here we are marking all the currents in a clockwise direction. So for mesh 1 I am marking the current as I1, for mesh 2 I am marking the current as I2, and for mesh 3 I am marking the current as I3. Here we see that this 3 ampere current source lies in a branch which is common between the meshes 1 and 3. So we can find out here a relationship between I1 and I3 in terms of the current which is made to flow in this branch. So here we see that this current is flowing from the top to bottom direction, and accordingly the net current would be I1 minus I3, and that happens to be here equal to 3 amperes. So now once we have marked all the meshes and the mesh currents, the step will be to write KVL equations for the meshes. Now here we see that for mesh 1 we can not write a KVL equation because there is no way to directly calculate the potential difference across the 3 ampere source. Similarly, the case will be for mesh 3 where we cannot write an equation because we cannot directly calculate the potential difference across this 3 ampere source. So first let us write the KVL equation for mesh 2. I am starting from this point, so the equation will be plus 2I2 plus 2I2 plus 4 I2 minus I3 equals 0. So here we had 3 variables I1, I2 and I3, and I have 2 equations. We need one more equation. So for that equation we will not use mesh 1 or mesh 3, but we will take a loop using which we can write the equation. So here I am taking an outer loop in a clockwise direction, and this is what we call as a super mesh. So I am writing the equation for this super mesh starting from the lower potential terminal of 6 volt source. So the equation will be minus 6 plus 2I2 plus 8I3, and that is equal to 0. So we had 3 variables here, and now we have 3 equations. So the final step will be to solve these equations, and since the current required was through 8 ohms, so we were mainly interested in the value of I3. So once you solve it, you get the value of current to be 0.4737 amperes.